Everyone, and welcome to Protecting Your Data with AWS Encryption. My name is Ken Beer, and I'll be your presenter for today. We have with us Shri Pishrodi, who is a Senior Product Manager from AWS. Shri will be our Q&A moderator today. A little background about myself. I'm the product owner for AWS Key Management Service, and I work in the AWS Cryptographic Services group. Before Amazon, I spent 15 years building enterprise-class security products for encrypted mail and gateway threat prevention. Before we begin, I'd like to walk you guys through a few items. On your screen, you'll see a Q&A panel. Please submit your questions at any time during the webinar. Shri will answer as many questions as time allows in the Q&A panel while I'm presenting. Towards the end of the webinar, there'll be a live Q&A session, and I will address some questions as well. As a reminder, this webinar is being recorded. We will share the recording and the presentation slides via email a few days after the webinar. So today what I'd like to do is to level set everyone on the fundamentals of encryption and key management. I'd like to provide an overview of the various ways in which AWS can protect your data using encryption. I'd like to help you understand how the AWS Key Management Service simplifies the process of encryption and provides it at a very low price. And finally, I'd like you to understand alternatives to the key management service like AWS CloudHSM and partner solutions that may meet your security goals. So let's start with a primer on encryption. So first thing you need for encryption is a key, and I'll talk about symmetric data keys. Asymmetric data keys is another type of key, but for the purposes of this example, symmetric will work fine. So I generate a random piece of data, 128 bits, 256 bits, and I have a key. I can now combine that key with my plain text data, file, image, database field, it doesn't matter what it is, and I produce encrypted data. Now this encrypted data can be stored anywhere because the security of the data is now a function of the encryption applied to that data. But I have a problem, and that problem is that I have a symmetric data key that I just used, and I have to protect it, because if anybody gains access to the encrypted data and the plain text key, then I have no way of preventing somebody from decrypting the data. So the best practice is to protect that data key by encrypting it. So we can use yet another key, called a master key. Ultimately, we produce an encrypted data key, and that encrypted data key can be stored alongside the data. Okay. We're getting some feedback that folks are not able to hear me very well, so we're going to see what we can do about that. Let me go ahead. So you've encrypted your data key, and now you have an encrypted copy of the key with your encrypted data, but what about the red key that you used? How are you going to protect it? Well, you could, of course, encrypt it. Let's encrypt it with a blue key. You've got a blue key to protect. How will you protect that key? Protect it with an orange key. We can go on all day with all colors of the palette. Ultimately, you have to have a key at the top of your hierarchy that you can get access to be able to unwrap the keys below it. So when you're looking at an encryption solution and a key management offering, I provide some questions you need to ask of your provider to understand whether the solution will work. First of all, where are the keys stored? So we've acknowledged that at some point there must be a plain text encryption key available for use. Is this key stored in hardware? Is this hardware you own? Or is this hardware that the cloud provider owns? Where are the keys used? Are the keys used inside client software that you control in your applications? Or is this used inside server software that the cloud provider offers? Who has permissions to use the keys? Are these human operators and applications that can use keys to encrypt and decrypt? Is this limited to users and applications you control? Or are you delegating the ability to use your encryption keys to your cloud provider to do work on your behalf? And finally, what assurances do you have that the answers to these questions are in fact true? Let me talk about a couple different general models for ways in which a cloud provider like AWS can offer encryption services. The first is server-side encryption. I've listed a handful of AWS services that support server-side encryption today. And the idea is that you are going to submit plain text data inside an API to one of these services. And once the service endpoint receives your data, it will then encrypt. And all of these services support an option where the encryption can be done with keys that are inside your account. Now, when you're making the call to these services over the internet, that call is always protected by TLS, and so you have an encrypted channel. However, that TLS connection has to terminate somewhere, and that data has to be decrypted before it's handed off to the service. So you really are trusting the AWS service to do the right thing with your data. The other option is client-side encryption. And client-side encryption is where you do the encryption yourself at the source of the data inside your application before you call an AWS Service API. And in this model, the encryption keys can be either ones that you supply, or they could be keys that are available inside your AWS account. And I'll explain how that works a little bit later. But the point is that the data that the AWS service, or any cloud provider at this point, receives is encrypted. They can't do anything with it. Server-side encryption shows up in a couple different ways. Inside Amazon S3, if you use the management console, you can see an option to select server-side encryption, and we give you various options about what keys we should use on your behalf. S3 has an alternate method for server-side encryption. It's somewhat of a combination between client-side and server. And the model here is that you provide the key along with the data as a part of the API call to S3. So for those of you who are familiar with S3, then you might be familiar with the put call. The S3 service will take the key that you provided and the data that you provided and encrypt it right there at the web server the minute we receive it. That data will then get stored in the back end for S3. The important thing to remember is the key that you gave us in this model is immediately deleted after we use it. We don't store that key, which means if you ever want to make a GET call to S3, you must provide the exact same key so that we can decrypt the data that we pull from storage and present you with plain text. Amazon Elastic Block Store, used in conjunction with EC2, allows you to create volumes that will have full disk encryption. Here inside the console, you can see an example of asking AWS to encrypt data on your behalf, and you get to make some decisions about the keys that are used. Amazon Redshift does the same thing. Again, when you're creating your cluster in Redshift, you can tell Amazon, when you write data to disk, I want you to encrypt and use this set of keys. So what are the client-side options inside AWS? So there are a couple different ways to think about client-side encryption. You could do it entirely yourself, or we provide some helper applications that at least give you some access to the cryptographic primitives and allow you to integrate your own keys before encrypting. So how would this look? Well, let's say you're starting with applications inside your own data center, on premises, outside of the cloud. Submit that data to a set of code, and these are toolkits that we provide inside our SDKs. But you are still providing the key, which is the gray material, All we're doing is providing the code that both encrypts the data as well as submits the data to the AWS service. The other option is you can have your data start inside AWS, maybe in an EC2 instance, an application that you own. And in this case, when you supply the key, you could pull that key from systems that you manage on premises, or they could be pulled from systems that are running in yet another EC2 instance. But again, these are all under your control. The point is the data that is received by these select AWS services, S3, Dynamo, is in encrypted form, and you are in control of the keys, and you are in control of the decryption of that data. So now let me talk about an alternative for key management called the AWS Key Management Service. So the service is a managed service that's designed to simplify the creation, the control, rotation, and the use of encryption keys in your applications. It's also integrated with several AWS services, both server-side encryption as well as client-side encryption. So all of the options that I've talked about previously in terms of services and toolkits that accept keys can also accept keys that are managed inside Key Management Service, or KMS for short. The other nice thing about Key Management Service is that it's integrated with CloudTrail, so that every action taken on your encryption keys is logged to CloudTrail for your inspection. This might support your regulatory or compliance activities to be able to prove the security of data. KMS is available in all commercial regions today, except China. So how do you use KMS? Well, through the console, you'll see that it's currently integrated with the Identity and Access Management console. We have heard from customers that they want their privileged administrators who are defining permissions for data security to be limited to a particular part of the console. And so encryption could be thought of as yet another form of access control. So there's an option in the IAM console for encryption keys. And here you see there's a table that's showing the keys that are available inside the service. There's two classes of keys. Keys with the golden cube are default keys created in the context of a service. So this means if you just want server-side encryption to happen, you don't care so much about the permissions on a key, you just want to have checkbox encryption, we will still create a unique key inside your account that can only be used by that specific service. Everything else about the key, all of its management and lifecycle, is transparently handled by AWS. The other option, though, is that you can create your own key. And when you create your own key, such as the top three in this table, you have full control over access policies around that key and its lifecycle. So how are keys used by other AWS services? We use a two-tiered hierarchy called envelope encryption. So if you remember the first slide, my encryption primer, you've got a key that's used to encrypt the individual resource. And in this case, we'll call that a data key. That key is unique for every resource. That means every S3 object, every EBS volume, every RDS database instance, Redshift cluster, so on and so forth. Those keys are unique to the resource. Those data keys are themselves protected by what we refer to as a customer master key inside KMS. Those customer master keys are the things that you manage. The benefits of envelope encryption? Well, it helps limit the risk of any compromised data key. A single data key maps to a single resource. You get better performance for encrypting large data, so you don't have to send big chunks of data back up to the KMS service and ask the service to encrypt it on your behalf. KMS will support that use case, but only for small pieces of data, for example, data keys. We also think that it's easier to reason about and manage a small number of master keys than potentially millions or billions of data keys, depending on how many unique resources you have inside AWS. And finally, because access to the data key to decrypt the data must come back to a centralized service, you can control access on how the master key is used, and you get full audit of the activity around that key. So let me dive a little deeper on exactly what happens when a service or your application interfaces with KMS to get keys. So, step one, the application says I need a key to encrypt a particular piece of data. It will call into KMS and request a data key to be generated. Now, this presumes that a master key already exists inside the service. So when I request a data key, what I'm saying is return to me a plain text data key, but also return to me a wrapped version of that data key. And that wrapped version is the data key encrypted by the master key. So now my application has a plain text key that can be used to encrypt my individual database field or my EBS disk or my RDS database. And I can store that key in volatile memory because I don't want that key stored on disk where it can be discovered. What I can store on disk is the encrypted data key, because if anybody discovers that, they can't do anything with it without submitting it back to KMS. And if they don't have the proper authentication and authorization to use that key, they can't decrypt the encrypted data key. So the plaintext data key is stored in memory for as long as it's needed. If this were an S3 use case, the S3 web server uses that key to encrypt or decrypt your object and then deletes it. So it's present in memory for a handful of milliseconds. If this is an EBS volume or an RDS database, at that point the key is actually kept in memory on the AWS service host for as long as your volume or database is attached. The reason we do this is because we want to provide very high I/O. When you purchase a EBS database, an EBS volume or RDS database, you're often purchasing provisioned IOPS. So you want 5, 10, 15,000 IOPS on that disk. In order to deliver that by encrypting and decrypting every I/O, the key must stay in memory. So as long as that volume or database is active, attached, the key remains in memory. The minute you detach or terminate that instance, the key disappears. So what are the interfaces to use KMS? Well, if you recall from a few slides back, when you're creating something inside the console, we give you an option to select the master key. So this drop-down would give you a list of all of the master keys that are available inside your account and managed through KMS. We give you some metadata about this key to reinforce that this is in fact the key that you're expecting to use. You'll see at the bottom here we have a key ID, which is a GUID. We also support key IDs in the form of an Amazon resource name or ARN. So when you're using the CLI or the SDK and you need to pass in this encrypted flag in the third line, you can also add the key ID that you want to use from KMS. So in this case, when you're creating an EBS volume, EBS will know, this particular user wants to create a volume. I will give it a unique volume ID. And I will pass the request to KMS so that I can get a unique data key to encrypt this unique volume. Perhaps the best security control around KMS is the fact that you get control over how and when your keys can be used and by whom. So let me give you some sample use cases for permissions on a key. You could build a policy that says this key can only be managed by this group of users. So you might have a set of privileged SecDevOps team members who are creating encryption keys. They are the only ones who have the ability to create them, disable them, rotate them, and change any of the policies on those keys. Remember, master keys very quickly become very important pieces of data that can affect the availability of lots of resources below them. So you may want to have your keys controlled in a single account by a single group of users. You can build a policy that says these keys in existence can only be used for encryption and decryption by this group of users or this group of applications. For those of you familiar with AWS Identity and Access Management, you know about user policies and IAM roles. So you can dictate which sets of users can call encrypt or decrypt APIs to be able to use keys. You can split the usage. So you could have application A is allowed to encrypt data, but only application B, under a different set of credentials, can decrypt data. You can put further restrictions on the ability to call KMS APIs, such that you may want to ensure that the application or person that is trying to decrypt data is only allowed to do so if they pass additional parameters that are unique to that data. So you could imagine encrypted customer PHI or PII can only be decrypted if the application also passes another partial identifier of the customer, so some public piece of data, and that data could come from another system. So these controls help mitigate concerns around people who might get access to encrypted data, who might otherwise have AWS accounts that would give them access to the KMS service. But you can control all the conditions under which people are allowed to decrypt the data. And of course, all of the APIs for KMS are fully integrated with AWS IAM. So you can apply these policies to individual users and IAM roles. You can also apply these policies directly to the keys themselves. So you can understand exactly which sets of users have access to this resource, a KMS key. So very flexible. Let me talk a little bit about the logging or auditability of key management. So if you have lots of automated applications that are encrypting and decrypting data on the fly, it's very important to be able to prove that a particular key was used, which essentially proves access to a piece of data. So what I've done is I've extracted some relevant lines from a CloudTrail audit log that talks about KMS APIs. So in this case, the KMS API decrypt result was handed back to a requesting client. At this particular time, in reference to this particular key, so this is the 32-character GUID that represents the key ID, to protect this particular resource. So this encryption context field is actually something that KMS has invented as a way to give you some information about why a given master key was used. Because when KMS receives requests, all it knows is that it's encrypting and decrypting data. It doesn't necessarily know what that data is. In fact, it's better that it doesn't know what that data is. But you, as the owner of the key, you would like to know something. So we include metadata. In this case, this is a volume ID, so that you know that this key was used by the EBS service or EC2 service in response to a request to decrypt a volume, which means that volume was attached to an instance, and the decryption key was made available to the instance so that all I/O could be decrypted off of that disk and re-encrypted when written to disk. You'll see the request for this decrypt API came from this IP address, and the AWS identity was this user 123 under this account. So this answers all the major questions that you need to know about why keys were used, when they were used, and for what purpose. So here's a sample list of the various APIs that are available inside KMS. So I've talked a lot about how KMS can be used in the context of other AWS services when you want AWS to encrypt data on your behalf. You can, of course, use KMS standalone inside your own applications through the AWS SDKs to do your own encryption inside your own application. If you need to encrypt specific data inside a copy of your database running inside EC2. You can use KMS directly to be able to generate data keys, to submit data directly to KMS. You can manage keys through the management APIs. A full list of the APIs and the documentation for KMS is at the link below. So if you remember from my key questions to consider slide, you know that all of the usability around KMS means that AWS is doing a lot of the heavy lifting for you in terms of storing these keys securely, controlling access, and providing high availability and higher performance. So why should you trust AWS with your keys? Well, we do a lot of things to make sure that there is no unauthorized access to your keys. First of all, we ensure that plain text copies of keys are never stored in persistent memory on runtime systems. They're only stored in volatile memory. If a key is ever written to disk, it must be encrypted. There is very formal separation of duties between the systems that use and manage master keys inside KMS and the systems that would use data keys to encrypt your actual data. So for example, the S3 web server or endpoint that's receiving your put request, the people who operate that fleet of servers cannot access KMS hosts. There's no ability for them to get access to master keys to be able to decrypt data keys that they might discover. Inside KMS, we enforce multi-party or quorum-based controls to ensure that no system that uses your master keys can be accessed by a single AWS administrator. There must be at least 2 people, and the approval process through that involves several other people as well. So a lot of these controls that we have in place for KMS and other services are documented inside our SOC 1 report. The March 2015 report is available for request if you go to the aws.amazon.com/compliance page. You can request all of our compliance reports. And the SOC 1 from March 2015 goes into detail about the security controls we have in place to prevent unauthorized access and use of your keys. So what is the pricing for KMS? Well, we have 2 pricing dimensions. When you create a key and you want us to store that key and protect the security of it and potentially rotate it on an annualized basis, we charge you $1 per month. And of course, that key can be used to generate any number of data keys underneath it. And those data keys can be used by AWS services. They can be used by your own applications. Those data keys don't cost you anything because we don't manage those data keys for you. We generate them, we return them to the calling client. So the other pricing dimension is API requests. So whether these are management APIs or data plane APIs, we charge 3 cents per 10,000 APIs. We give you 20,000 free API requests every month. So what are some alternatives to KMS? You may want a solution that gives you more control over the physical security of your keys. Well, there are 3 different options that you have. Let me talk first about AWS CloudHSM. CloudHSM is a service where we are effectively leasing you dedicated access to a hardware security module device or appliance. So this is your own box. It's racked inside our data center. We will provide power and network access to this device, but you are responsible for all the data inside this device. So what this means is when you first are provisioned one of these, you will connect and create keys on the device and be responsible for all client connectivity to the device for encryption and decryption. Now, these HSMs are provisioned inside your virtual private cloud so that you have some segregation and network security. You can connect these devices into other systems that are on premises inside your VPC. And these devices are actually provided by SafeNet, their Luna SA appliances. CloudHSM is available in 7 regions worldwide, with more on the way. CloudHSM is included inside our existing PCI DSS report on compliance, as well as the SOC compliance package. So how do people use CloudHSM? Well, it tends to be used for applications that you're managing yourself, or in some cases, there are a couple AWS services that provide an interface into CloudHSM. I'll talk a little bit about how this works. The next slide, you'll see that the link between a CloudHSM device and, in this case, encrypted data inside an EBS volume requires the use of some third-party client software in between, and specifically SafeNet. Since the devices themselves come from SafeNet, you can use solutions like ProtectV, Virtual Key Secure, where you're managing the client requests coming from your instance and your application to encrypt and decrypt data with keys that are stored inside the HSM. So the model with HSM, as well as the model with key management service, is that master keys that are created inside the device or service, as it were, can never leave. So you can only submit data to the device or service and ask that it be encrypted or decrypted. And so you can pass along data keys to be used inside your applications directly, but the master keys themselves never leave. Pricing for CloudHSM. Well, these are dedicated appliances. There is no multi-tenancy, and so you get the entire box and all of its capacity dedicated to you. There's a one-time charge for provisioning, and then a metering of a certain amount per hour. The amount starts at $1.88. It varies by region. And so your cost for year one includes a $5,000 setup charge, as well as the hourly rate for as many hours as it's up and running. Unlike key management service, CloudHSM does not bill per requests. So you can make as many requests as you want. You're limited only by the capacity of the device, and that capacity depends on the algorithm and key size that you're using. So why would I choose CloudHSM over KMS? Well, CloudHSM, again, gives you dedicated hardware. It has verified compliance with various government standards to prove that the cryptography is implemented correctly. You control all the keys, you control all the client access to the device, and this may be an appropriate choice if you already have applications that use cryptography and are tied into SafeNet devices or other HSMs that support various standards. KMS, on the other hand, provides you with a highly available and highly durable key storage solution. You don't have to worry about the durability of the device or the availability. We manage that for you. With CloudHSM, if you want high availability, you have to have more than one CloudHSM device, and you have to configure those devices and replicate data between them. That's your responsibility. With KMS, we handle that for you. So we offer you high availability and integration with lots of other AWS services. So the ability to do transparent server-side encryption is much easier with KMS. The interfaces to KMS include all of the AWS SDKs, as well as the ability to call other AWS services and ask them to do encryption on your behalf. The access control model is slightly different as well. With CloudHSM, you have to use passwords or key-based access control mechanisms with the SafeNet device. With KMS, you can use AWS Identity and Access Management and the concepts of IAM roles, IAM users. You have much more flexibility in terms of how you define who is allowed to access and use keys at any given time. So let me talk about some other options for you outside of AWS provided key management. We have several partners that have solutions in AWS Marketplace. SafeNet, Vormetric, Trend Micro, just to name a few. What they do is they provide virtualized instances of their server software that you can deploy inside your EC2 instance, and you will get a complete key management solution that could integrate with EBS to encrypt your EBS volumes. SafeNet offers a solution that will help you encrypt your S3 objects. As with most solutions in AWS Marketplace, you get to deploy these automatically with one click. You get to pay for them as a part of your AWS bill, and the licensing models vary. You can pay by the hour. You can also bring your own license in some cases. So if you're already using third-party software from one of these vendors, it may be simpler for you to simply extend that inside your own EC2 instance and manage that with your applications. And finally, there's a do-it-yourself model. So if you have the ability to manage your own keys, supply keys to your own applications, write your own code that does crypto processing, you can run that code on premises, you can run it inside EC2. You will control all the encryption and decryption before you submit data to an AWS service. So this has been possible ever since the cloud launched with EC2. You always have the ability to run your own code wherever you want. But of course, in this case, you're responsible for the security of the keys and their storage. You're responsible for the availability and durability of those keys. So this final table tries to go through some of the key questions that I asked about and compare the various options. So just to walk through this really quickly, the key management service, AWS is storing and protecting your keys. The keys are used either inside your own applications or by AWS services when you want them to use your keys. And you have complete control over how and when these keys are used. AWS provides all of the performance and scalability and provides an integrated experience through other AWS services. The pricing model, the price to get started can be as low as $1 per month and 3 cents per 10,000 API requests. With CloudHSM, you have a lot more control, but also a lot more responsibility. And the pricing model is slightly different. For as long as that box is up, you're paying an hourly fee. You could think about this as a specialized EC2 instance, even though it's actually a dedicated piece of hardware. Marketplace solutions. You may be running these inside your own network. You can run them on top of EC2. The way you control access to the keys, completely dependent on how the vendor controls that. So there is no integration with identity and access management in terms of roles or any authorization rules. And again, you're responsible for all the performance and scale of this to the extent that you can create multiple instances inside EC2, you may get the scale you need. And finally, do it yourself. Perhaps the ultimate in control, because you manage all aspects of encryption and key management. This gives you complete flexibility to do what you want. So here's a list of resources that you can go to learn a little bit more about the key management service, as well as a review of the options that I presented today. We provide some technical white papers that describe what's happening cryptographically inside the key management service. We also provide some details on some of the encryption clients that you can use locally. And we recommend you subscribe to the AWS security blog, because we're always publishing new and interesting blog posts about how to use identity and access management, as well as KMS and other security controls to protect your data inside AWS. So I want to thank everybody for their time. Before we launch into the Q&A, I want to remind folks that we have an upcoming AWS Summit, July 1st in Chicago. This is an opportunity for you to come and listen to various AWS speakers and customers talk about what you can accomplish inside the AWS cloud. You'll hear about new product launches. There are various offline sessions that will let you work hands-on with some of the services and the technology. And the link here at the bottom of the screen, you can also search for this on our site, allows you to register. So as a reminder, for those of you who may have been trying to take notes frantically or screenshots, these slides will be made available, as well as a recording of the presentation.